thing we're going to talk about solving linear equations, okay? So when you're solving a linear equation, we're just talking about solving equations. Linear just means that your variable in there has a term or a power of 1. That's it. So any equation, we'll just throw one up real quick and we'll make it super ugly. Let's go ahead and solve these. So if I wanted to solve that, like what would I do? How's my approach? How do I deal with that? All that stuff. What you got to understand is when you're doing any solving of an equation like this, you're actually tearing the equation apart. So if you imagine anytime you put something together, for instance, you buy something at a store that needs to be put together, like you go to IKEA, get a piece of furniture, or you buy anything in a box that you have to assemble. You have directions with which to put that together. Math's the same way. So when we put math together, we have directions, we have steps we have to follow. And what steps do we follow when we put math together? Order of operations. Order of operations are, and I'm not sure what your teachers before you taught, but I know a lot of us go with this. There's parentheses, exponents, multiplication, division, addition, subtraction. Don't remember parentheses, exponents, multiplication, division, addition, subtraction. It's parentheses, exponents, multiplication and division, addition and subtraction. These guys occur on the same level. So the thing is, that's how we put math together. So when it comes to solve an equation, what I'm doing is I'm trying to get that x all by itself. Here's the math. It's put together. Now, it hasn't been done because there's variables in there, so we can do it. So what we say is, well, I want to tear this apart, and I want to get this all the way down to x equals something. That's where I'm going. So I've got to tear this math apart. So when you take something apart, if you can imagine like assembling something that you bought, comes home in a box, you start putting it together and you get to step whatever, let's say 7. You're missing a part, and now you've got to tear it apart, put it in the box, return it to the store. What are you going to do? Well, if I'm at step 7, I've got to go back to step 6, undo that, step 5, step 4, step 3, so forth and so on down the line. So that's what we're going to do. We're going to tear this apart, which means we're going to follow the order of operations backwards. And one more thing that I want you to understand is, like when it comes to taking something you build apart, like if you put a bolt in here, it's right to tighten it, left to loosen it. So we got to do the opposite thing. So when we're tearing this math apart, not only are we following the order of operations backwards, but we're going to use the inverse operations, okay? So hopefully you remember that stuff that was taught to you by your previous teachers. Let's burn through one real quick. We'll talk about a couple things, then we'll be done. So if I wanted to solve this, there's actually a couple ways I can approach this. I think a lot of you would look at this and scream distribution, and you can do that. If you want to distribute this, you can. It can also be torn apart piece by piece, and that done at the end. I'm going to go ahead and say let's distribute that, because then I can put more things together, and then I have less to tear apart. So this, of course, stays as 2x plus 4. When I distribute that, that becomes 3x plus 12. And then plus 3. Since these guys are like terms, I can put them together, and I'm looking at 3x plus 15. Now, this is the part where now I have to get x by itself on one side. You can pick whatever side you want and make that happen. My suggestion to you is to get into the habit of choosing the side with the least amount and getting rid of it. So when I look at this, I'm going to choose to get rid of the 2x. The reason I'm doing that is you've not done a whole lot of work with inequalities, but you will. And when you get to those inequalities, you want to keep the coefficient of your variable positive. By choosing the smaller one and getting rid of it, you will keep it positive. So 2x is a smaller one. I'm going to get rid of that guy to get rid of that 2x. Well, how do I make him disappear? Well, he is a positive 2x, so I'm going to subtract 2x from both sides. Because after all, positive 2x minus 2x, voila, gone. So that gives me 4 equals 3x minus 2x is 1x, or just x. I'm going to put the 1 there, but it is not necessary. So now this guy, that should be very easy. That's a 2-stepper. You can turn and burn on that. So we are going to subtract 15. 4 minus 15, of course, is 11, negative 11, and that equals 1x. And of course, at that point, if this was any other number, we would divide it out, but we don't need it. So we have x equals negative 11. I highly suggest you take that, substitute it back into your original problem, and check. You've come this far. you can grab your calculator and punch this side in, 2 times negative 11 plus 4, and 3 times negative 11 plus 4, and then plus 3. You can put that in real quick, and you could wind up having actual like confirmation that it worked that way. Sorry, my phone was not silent. So that's it. Now, I want to point out a couple things when you're doing this is when I'm looking at this and solving this, there's 2 unique situations that occur. Situation number 1 is that, both situations arrive from the same thing. And I'm just going to pretend we were solving this, and at some point we ran into it. At some point, I ran into 3x plus, that was 2x. Let me run it down. I had 2x plus 4, and on the other side equaled 2x plus 15. When that happens and you try to pick the side with the least amount, you can't. What are you going to do? Well, just pick one and get rid of it. Because after all, if I say, all right, I'm still going to get rid of this one here on the left. If you do that, both things disappear and you're left with 4 equals 15. Now, if that happens, whenever that happens, your variables are going to cancel out. You're going to be left with a statement. Okay? The question is that statement true? That statement is not true. 4 does not equal 15. So what does that mean? That means you were working with an equation from the start that was unsolvable. There is no solution here. Okay? If, on the other hand, I'm just going to work a little bit backwards here. If, on the other hand, it had looked like this from the start, when you subtracted the 2x from both sides, you'd have been left with 4 equals 4 at the end. So the variables still canceled out because they were the same thing on both sides. You picked one, you knew they were going to go away. They went away. Now that the statement is true, guess what that means? That means whatever equation you were working with from the start and got to this, any number would work. It has all solutions, infinite solution, all real numbers, however you want to say it. Okay? And we can talk in class when we get there about like symbolism for that as it comes. No solutions. You can write it, the empty set looks like that if you want. You can also write it as set brackets without it. All solutions. I think for state purposes, they always say infinite amount of solutions. You could say that all solutions, all real numbers, any number will work in this situation. So for now, we'll roll with that infinite amount of solutions. I'll just leave it as that for right now. You've seen it, you've done it, all that stuff. So that's basically where it comes from. Hopefully that helped. Talk to you later.